polar regions are one of really the most crucial parts for our whole worldwide Earth climate system. Because even though they are really far away for every individual back home, wherever home is, they're super crucial because they're kind of the fridges of our Earth system. So when you're wherever you live and you have winds, in the atmosphere, you have atmospheric conditions, you have the ocean, and all these atmospheric circulation patterns and drifts in the ocean, they are in the end all forced in the polar regions. And this is in both regions, both in the Arctic and in the Antarctic. Which means when we now talk about today's climate change, that means the area where we are living is changing, but the reason and the main cause for these changes are changes in the polar regions. We need to understand what is happening in the polar regions in order to understand and kind of counteract on what is happening also in our regions. We look on the one hand the really obvious factors as how thick is the ice, how thick is the snow. But then we go in even more detail and look how does the structure of the ice look like and how does the snow structure look like. That means for the ice structure we do take ice cores, which we analyze for exactly that. In addition, we took many more ice cores for biological sampling and seeing how much biology is in the ice, how much biomass. And then for the snow structure, this is my most favorite work, I would say. So this is really when I look in real detail into single snowflakes. And this again, really literally. So meaning I look into the structures within the snow. How does these different structures look like? How do single snow grains look like in order to get an idea of the vertical profile? A huge part was also putting autonomous sensors on the ice floes. And these autonomous sensors, they now still sample also when we are not around and measure, for example, snow depth or sea ice thickness. And these systems now drift with the ice through the Weddell Sea and send their data once per hour back home so that we can still see how does the ice that we sample is evolving now over the next weeks and months in an ideal case. We come back on board, take the ice cores, cut them in half, and take slices out of roughly half a centimeter.
This is actually...
And these thick sections we then can put on our light table, where we then analyze them in polarized light. And this polarized light allows us to get really internal ice structures. I mean, definitely when it comes to sea ice work, it's all about the team. They need to enjoy the cold, they need to enjoy the challenges, because you're always kind of dependent on the team. And also the team can make, only the team can make in the end the real success of the project.